Okay, in this video, I'm going to provide some demonstrations of how you can obtain logistic regression output using R. And what I have in the data set in R right now, I've already have a data set in there. And it's found under a data object called MyData. And so just to take a quick look at it, you can see that the variables that are include donate, gather, write, contact, gender, political interest, dogmatism, external political efficacy, and so forth. So what we're going to do is we're going to run a logistic regression using donate, which is coded 0 and 1, reflecting intentions to donate to a political cause as a dependent variable, and interest in politics or political interest and dogmatism included as predictors. So basically, to start off with, what we need to do is to lay out the basic model. And so right here, you'll see that I've laid it out. And essentially what we're doing is we are utilizing the GLM function right here for generalized linear model. And the basic idea is that we're going to perform the analysis here and then save the analysis under a data object called myLogit. So you'll see right here the donate variable is the dependent variable, followed by a little tilde sign, followed by first predictor plus second predictor, then comma, and then we need to specify where the data is being taken from. So the data file is my data. So I have data equals, and then the name of the data object, which is the my data that I've already laid out. Then a comma, then followed by family equals, and then inside quotation marks binomial. So we have to indicate that we're using binomial distribution. And so there you go. So then what we'll do is we'll use the summary function in order to look at the output. So we'll go on into the R program and we'll lay out our command. So first off, I'm going to lay out the actual analysis into a data object called myLogit. We have an arrow pointing to it, and then we're going to type in GLM for generalized linear model. And inside the parenthesis, we're going to type in the name of the dependent variable. So the name of the dependent variable is donate, and it's all in caps, so we want to make sure to leave it as such when we're typing this in. Follow it up with a tilde sign, and then POLINT, that's political interest, plus DOG for dogmatism, basically. And then, so those two variables were also all in caps. Then comma, and then we'll type in data equals, then my data. So we're going to be reading the data from the data object that I was just kind of commenting on, and follow that up with a comma, and then family equals, and inside quotation marks, we'll type in binomial in quotation marks and then in parentheses. So the basic structure that we're working with whenever you're running a logistic regression will be using GLM as the function, and then inside the parenthesis we'll include the actual function itself. The donate is a function of, in this case, political interest and dogmatism, the two predictors, comma, then note the data source, which is our data object, or in this case our data frame, and then the family from the GLM families. So at this point we'll hit enter, and then we can type in summary, and inside parenthesis we'll type in myLogit. And so when we hit enter, you can see right here that we've got a number of pieces of information. You have the basic GLM formula that we had laid out previously, binomial family laid out, and so forth. And then you'll notice that we have our regression coefficients. So these are we have the coefficients for the intercept as well as the two slopes for political interest and dogmatism. There's standard errors and z-values, and also we have our p-values. And you can see that also given our little asterisks right here, which are denoting the level of significance for the model, or for the individual coefficients in the model. You also notice that we have deviance values. Null deviance is from essentially an intercept-only model with no predictors, and the residual deviance is from the model incorporating the predictors. So You'll notice that there's no chi-square test or anything like that right now. If you were to run this analysis through SPSS, you would get essentially a chi-square test to test the significance of the overall model relative to a null model. And unfortunately, it doesn't default that way in R. So what we need to do if we want to get that information is we're going to have to go a little bit further. And so looking at our little document right here, we're going to be carrying out essentially a chi-square difference test. And in this particular case, you'll see that it says basically we need to obtain three pieces of information. So first off, you'll see we have a with command right here. And then in parentheses, we have my logit. So we're calling back the information contained above in our data object for my logit. So then you'll notice we have a comma, the null period deviance, and then minus deviance. So basically we're going to be obtaining the deviance value from the MyLogit object minus, that's from the null model, and then the deviance from essentially the residual model. So then the next step is we will use the with command and then follow it up with MyLogit again. And then we're going to get the degrees of freedom null and degrees of freedom residual. So we're going to be typing in df period null minus df period residual. And so we'll get that as well. And then this last one is actually carrying out essentially the chi-square difference test. So you'll notice we have with, and inside parenthesis, inside our parentheses, we have first our data object again, the MyLogit, comma, PCHISQ. So, and then inside that parenthesis right here, we're going to have null period deviance minus deviance. So that's going to be the difference in deviances, comma, then df null minus df residual. So that's going to be the difference in degrees of freedom from the intercept only and our full model, and then comma, and then we have lower dot tail equals f. And so that's all there is to it. So it looks probably a little hairier than it really is. So just typing this in, we'll start off with, and then inside our parenthesis, we're going to refer back to the MyLogit data object containing our GLM results. Then comma, and we'll use null period deviance minus deviance. Okay, so when we hit enter, you can see it. And so basically all this is, you'll see we have the null deviance right here, which is 171.62. So that we're calling that up and subtracting the residual deviance right here. So that's what's going to get us our 28.11 that you see right here. So next we'll type in with, and then we'll type in, again, our data object. So let me retype this again. My with, MyLogit, and then we'll type in df period null minus df period residual and hit enter. And so now you'll see it's a 2. So that's not a big surprise. It's just basically taking the difference in these degrees of freedom over here. So the last piece is a little bit more work, but well worth it. So we'll type in with, then MyLogit, and then we're going to type in PCHISQ. Inside parentheses, we'll type in null period deviance minus deviance, comma, df null minus df residual, comma, lower period tail equals f for false, or you could just type in false, and we'll put our two, close out the parentheses twice there, and hit enter. And so there you go. There's our test right here. So, you know, basically, you don't really actually have to do all these other two steps right here. I mean, if you just wanted to do the test itself, you can get the p-value by, you know, just running it this way if you wanted to do that, and you can manually compute those differences there. But this is just kind of getting you all that information. So this is essentially the 28 is the chi-square difference value between the null and the full model. This right here, we're getting the degrees of freedom for the chi-square difference test, which is 2. And then this is the p-value for our test. So next up, let's say that we want to obtain confidence intervals for the regression coefficients. Well, then we can actually use this little command right here. So you'll see it says CONFINT, and then inside the parenthesis it says mylogit, referring back to our data object containing the GLM results. So we can do that. We can just type in CONFINT inside parenthesis, referring back to our data object again, and then hit enter. And so there you go. There's our essentially 95% confidence interval that you see right here. So next up, let's say you want to obtain the odds ratios from the logistic regression. So we can use EXP, and then inside parenthesis, you'll see COEF for coefficients, basically. And then inside a subsequent parenthesis, referring back to our data object. So let's do this. So we're going to type in EXP, then inside parenthesis COEF, excuse me, and then we'll get the name of our data object from the GLM results. And then be sure to close out the parentheses, and we hit enter. We now have the odds ratios associated with, there's our intercept, our odds ratio for political interest, and then dogmatism right here. So there you go. Now, let's say for argument's sake that you want to form a confidence interval for the odds ratios. Well, we can do that as well. What we can do is use this set of commands down here. So you'll see it says EXP, and then inside parenthesis, cbind, and then inside another parenthesis, you'll see OR for odds ratio equals COEF for coefficient. And inside the parenthesis, you have, our data object name in parenthesis, and then a comma right here, and then CONFINT for confidence interval. And that's what we were doing right up here previously. And then you've got the mylogit data object yet again. So in this particular case, what we'll do is let's just type it in. We'll type in EXP. Inside a parenthesis, we'll start with cbind. Then inside another parenthesis, or starting another parenthesis, is OR equals COEF. And then mylogit, which is the name of our data object containing the GLM results, and then comma. And then we'll type in CONFINT. And then inside another parenthesis, we'll refer back to our data object yet again. And it's a little tricky with the in parentheses, but hopefully you have it. Yes, we do. All right, so at this point, now we have the odds ratios that we had previously generated above, as well as the 95% confidence intervals for those odds ratios. So basically, that's all there is to it. So at any rate, that's where we can get a good bit of our information. There is a package in R that's also available for carrying out logistic regression. It's actually called RMS. So what we can do is, if you want to carry out your logistic regression using this package, there are a couple of other things that you can get from that maybe you can't get this other route, or more directly through this other route. So what we'll do, just to illustrate it, is I'm going to go ahead and just install the package. So I'm going to type in install period packages, and then inside a parenthesis we'll type in RMS, and then and make sure that's in quotes, and then close out the parenthesis and then hit enter. And so now you can see basically, it's saying, hey, we want to download the package, but where do you want to download it from? So there are various mirror sites. So I'm just going to go to USA. I'm in Oklahoma, so I'll just stick with Kansas right here. There you go. So it's basically downloading it, and I think it's already actually I actually had already downloaded it, so it kind of looks like there's a little bit of a warning message, but basically it's already on the computer. I'd already downloaded it previously. So so what we'll do is, so if you haven't installed it, you'll need to if you're going to go through this route. But then, following that, you don't have to keep reinstalling it. But we do want to call up the package using the library command or library function. So we'll type in library and RMS, and inside the parenthesis, and it's now been called up. So This last little piece right here, what we'll do is we'll essentially run the model. It looks very similar to what we had previously before when we were using the GLM function. In this case, I'm just going to create a new data object that's called LR model. And this was just a name that somebody used on the internet, so I just kind of went with it. So just keep in mind that the naming of the data objects is pretty much arbitrary, but the actual function and everything else, you'll need to have correct. So we'll have our little arrow and then LRM, and then inside of parentheses you've got your dependent variable, then tilde, then your IV1 and IV2 separated by a plus sign. You'll see that I have the data equals and then referring back to my data, so the original data frame. So in this case right here, let's go ahead and type it in. So I'm just going to call this LR model and then have our little arrow and then LRM. And inside the parenthesis, I'll type in donate, tilde. There's our political interest plus dogmatism variables right there, comma, data equals, and I refer back to the original data frame, which is my data. And then in parenthesis and then enter. And then if I want to see it or see the summary of the output, then I can just type in LRM ODEL. So basically it's a logistic regression model. So in this case, we'll hit enter, and there's our output. And so you can see in this case that looking at it, you can see there's the basic model again, the source of the data. You'll also see you've got the likelihood ratio chi-square, which is what we computed manually about 5 minutes ago. So all of this stuff, where we previously had to use all the with commands and so forth to do this, we were able to generate this automatically using this RMS program. You'll also notice that you have a pseudo R-square value. That's the Nagel-Kirke pseudo R-square. Then you have the coefficients right here, the regression coefficients here, the standard errors, z values, and then the p values that are given right here. So this is yet another way that you can run a binary logistic regression through R. And you'll notice that you do get a few more pieces of information maybe than what you had previously, or that you had to work a little bit harder for when you were running it through the GLM option.